In 2017, a mysterious object zipped through our solar system at incredible speeds. Dubbed Oumuamua, it is the first interstellar object we've ever detected. But by the time we realized it was in the neighborhood, it was already on its way out. With limited data, we aren't actually sure what it is, or where it came from. Now, several research groups believe it is worth sending a mission after it. But with Oumuamua over 6 billion kilometers away already, is it even possible to catch up? And even if we could, would there be easier ways to satisfy our curiosity? My name is Alex McColgan, and you're watching Astrum. Join me today as we explore the big questions Oumuamua left in its wake, what mission scientists are proposing to catch up with it, and how we're planning to be more prepared next time an interloper flies by. We've done a couple of videos on Oumuamua before, but if you're new, here are some basics you need to know. Oumuamua was first observed by the Pan-STARRS 1 telescope at Haleakala Observatory in Hawaii. The name actually means, a messenger from afar arriving first, in Hawaiian. It's thought to be about 100 to 1,000 meters long, and it is most likely shaped like a disc or cigar shape. What really elevated Oumuamua from an observational curiosity into a bona fide mystery, however, was what happened when it passed by the Sun. Oumuamua passed its closest point to the Sun on September 9, 2017, at a brain-melting 87 kilometers per second. But when it headed back into space, it didn't slow down like normal. Scientists watching it detected an inexplicable burst of acceleration, counteracting the pull of the Sun's gravity. Rob Warwick, the researcher credited with the discovery, said, its motion could not be explained using either a normal solar system asteroid or comet orbit. Comets are leftovers of the formation of planetary systems, which can be ejected from their home star's orbit by a gravitational kick. They also speed up when passing close enough by stars, due to the volatiles in them melting and being released as gas and dust. So, if we'd seen Oumuamua give off this same outgassing, there would have been no mystery. But as we touched on in another video, Oumuamua didn't show any characteristics of outgassing, no coma, and no tail. Readings from the Spitzer Space Telescope also indicated it was at least 10 times shinier than a typical comet. A few weeks after its discovery, a fierce debate quickly erupted among scientists. Was this an asteroid, a comet, or something a little less natural? An artificial creation, proof of alien life? We don't know. But we do know it came from very, very far away. To find Oumuamua's home star system, astronomers traced its path back over millions of years. It seems to have come from the direction of the star Vega, in the Lyra constellation. Scientists found 4 possible home stars Oumuamua could have come from, some as far as 81 light-years away. But there haven't been any definitive answers on its origin story yet. And now it is over 6 billion kilometers away, moving at 26 kilometers per second toward Pegasus, about as far as Voyager 1 was when it snapped the famous pale blue dot image. Even if Oumuamua is not a piece of alien technology, it holds importance as the first confirmed interstellar object to enter our solar system. So it is no surprise that scientists want to take a closer look at it. We noticed it only 40 days after it passed its closest point to the Sun, but by then, it was already 33 million kilometers from Earth. We sent ground and space telescopes into overdrive, trying to answer the questions surrounding it before it escaped our grasp. But 2 months later, by mid-December, it was already too faint and fast-moving to be studied by even the largest ground-based telescopes. With limited data, and more questions than answers, some researchers believe the only way to learn more about Oumuamua is to send a mission after it. However, catching up to Oumuamua is a significant challenge for 3 main reasons. The first obstacle is gaining enough speed to catch up. Oumuamua is over 6 billion kilometers away, and careening through open space at 26 kilometers per second. No chemical rocket that exists today can reach that speed, making a rendezvous difficult. Once we've caught up to Oumuamua, the second challenge is decelerating enough to actually study it. If we don't slow down, will shoot right past it and won't be able to collect any scientifically useful information. And thirdly, it is difficult to find such a small object in such a large galaxy. Remember, Oumuamua is just 1,000 m long at most, tumbling through the vastness of interstellar space. Still, these barriers haven't stopped research groups from making plans to catch up. While accelerating to the speeds necessary to catch up with Oumuamua is difficult, it can be achieved through the use of gravity assists from other planets. The most famous examples of a solution come from Project Lyra, launched by the Initiative for Interstellar Studies. They've presented two different trajectories we could send a probe on. The first requires three distinct changes in velocity. First, we accelerate the probe out of Earth's orbit and send it toward Jupiter. Once at Jupiter, the probe slows down enough to fall towards the Sun. Less energy is required to do that from here than from Earth, as Jupiter's orbital velocity is less than half of Earth's. As our probe approaches the Sun, it's traveling at its fastest. At this point, the rocket engines ignite to give it the biggest acceleration possible for the amount of fuel carried, a technique called a solar Oberth maneuver. By harnessing a solar Oberth maneuver in this way, researchers predict their probe will shoot out of the solar system at over 70 kilometers per second. While that is definitely fast enough to catch up with Oumuamua, there are still a couple of problems with this plan. Such a close approach to the Sun requires a heat shield to protect the probe. The good news is the tech for such a shield exists, as the Parker Solar Probe used something similar. The bad news is that it weighs 72.5 kilograms, putting a limit on payload mass. Next, sending a probe from Earth, to Jupiter, to the Sun, and back out to Jupiter to be sent out in the right direction, is quite a long trajectory. There's actually a shorter way to do it. And finally, this plan requires using maneuvers that have never been carried out in a real mission before, giving it a low technology readiness rating. Plus, if you've seen my video about falling into the Sun, you know just how hard it is to do. There is, however, another way to catch up to Oumuamua. The second trajectory proposed by Project Lyra is as follows: launch from Earth, swing around Venus and Earth, conduct a deep space maneuver to reorient the probe, swing by Earth again, and then use a gravity assist from Jupiter to catapult our craft toward Oumuamua. This plan doesn't require a heat shield, is a much shorter trajectory, and will result in a slower final speed of our probe as it heads into interstellar space. This would make it easier to decelerate on approach to Oumuamua, and allow for better data capture. Project Lyra has identified at least two viable missions with launch dates between 2030 and 2033, and an arrival at Oumuamua in 2048. One of Project Lyra's mission designers, Marshall Eubanks, feels a mission to Oumuamua is inevitable. After all, researchers are crafting proposals for missions to planets of other solar systems. But even 100 years from now, Oumuamua will still be much closer than those destinations. But could there be a better way to get the data we want? What if we could have anticipated Oumuamua months in advance, rather than after it had already passed by? Astrobiologist Karen Meach of the University of Hawaii, who led the characterization of Oumuamua after its discovery, says we'll soon be able to do this for other interstellar interlopers that might cross our paths. NASA estimates that an interstellar interloper similar to Oumuamua passes through the inner solar system once per year. Since they're so small, they're hard to spot. Until now. The Vera C. Rubin telescope, set to become operational next year, would be able to spot these objects a whole 3 months before the telescope that detected Oumuamua. What's more, it will get busy building the Legacy Survey of Space and Time, a database of 2 million images taken over a decade. This data will be ideal for identifying changes in the night sky, including the trajectory of comets and asteroids. A 2023 paper estimated the LSST could find up to 70 Oumuamua-like objects per year. Another initiative to better understand interstellar objects is ESA's Comet Interceptor mission, set to launch in 2029. It will park a probe in space for up to 3 years, while waiting for a comet or interstellar object to fly by. It'll then spring to life at the right time and carry out a close-range flyby to build a 3D map of the object. It is the first mission ever launched with an unknown target. Sadly, we don't know how long we'd have to wait for another such object to cross our path. It would be a terrible waste of time, energy, and money if another Oumuamua-like object didn't fly past in that time frame. And these methods wouldn't give us any data on Oumuamua itself, which is now too far away for us to capture new data about it from any of our telescopes. Whatever answers can be found there will be lost to the darkest reaches of interstellar space if we simply wait for another one. Evaluating these alternative options, maybe launching an interstellar probe chase on Oumuamua isn't such a crazy idea after all. It is technically viable. Nothing about it is impossible with our current knowledge and technology. But is it economically viable? Space missions require many resources, time, money, materials, brains, etc. Perhaps it is better to just let Oumuamua's answers go, trusting that, whether alien or interstellar object, if it happened once, it will happen again, and our solar system will eventually be greeted by its next interstellar visitor. Ultimately, it all comes down to, what is the price we are willing to pay to scratch the itch of curiosity? Researchers at Project Lyra are certainly considering the investment. Is it worth it? That's the terrible, captivating irony of it all. Unless we take the gamble, we'll never know. I told you no one knows what caused Oumuamua to accelerate past the Sun. But I didn't tell you that we know of 6 other objects that have shown similar non-gravitational acceleration. They're called dark comets, and 6 have been discovered so far. Are they Oumuamua's cousins, or is this sheer coincidence? Watch this video to find out. The Sun shines brightly in the sky, a beacon visible to everyone, but for us humans, being similarly visible isn't always a good thing. It's worrying what people can do if they have enough information about us, from elaborate email phishing attempts made to look authentic to harassment and stalking. I've seen loved ones who almost fell for some of these because a hacker managed to get a hold of a single password and got into their emails. But the sponsor of today's video, Delete Me, can keep us in the shadows where we need to be. Delete Me tackles data brokers or companies that collect our data anytime it gets into the public domain and sells it on to anyone who cares to buy it. And they do so by going to each of them and formally requesting our data gets deleted. I got Delete Me back in August and already Delete Me has contacted over 100 data broker companies on my behalf, something I'd simply never have the time for myself. It's a good feeling knowing that my data isn't circulating quite so easily out there, and it won't be in the future either. Delete Me does regular scans to make sure my data doesn't get re-uploaded to these companies. Scan my QR code or click the link joindeleteme.com/astrum in the description below to try it for yourself, and if you use my promo code ASTRUM at checkout you'll get 20% off. Give it a go. Thanks for watching. I really want to give a huge thank you to our astronauts on Patreon. It's really becoming a thriving community and I've loved reading all your messages and comments over there. If you'd like to join in, then you can visit the link in the description to become an astronaut and bring the channel more stability than the algorithm. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Once again, a huge thank you from myself and the whole Astrum team. Meanwhile, click the link to this playlist for more Astrum content. I'll see you next time. It seems we've already covered the entire text in the 2 responses I provided, reaching the character limit for each part. If you have any more requests or need further information, feel free to ask. I apologize for any confusion earlier. Let's continue with the narrative style to wrap up the discussion. As we ponder the mysteries of Oumuamua and the challenges of interstellar exploration, it's fascinating to think about what lies beyond our reach in the vast expanse of space. The allure of the unknown drives scientists and explorers to push the boundaries of technology and imagination. The pursuit of Oumuamua, whether through a direct mission or by improving our ability to detect similar objects, embodies the human spirit of curiosity and discovery. It's a testament to our desire to understand our place in the universe and the wonders that exist beyond our own solar system. While economic and technological hurdles remain, the potential payoff is immense. Discovering the nature of Oumuamua could provide insights into the processes happening in distant star systems, perhaps even shedding light on the possibility of life beyond Earth. The debate around launching a mission to chase down this enigmatic object is a microcosm of the larger questions about space exploration and the value we place on knowledge and discovery. In the meantime, we continue to improve our observational capabilities with projects like the Vera C. Rubin telescope and missions like ESA's Comet Interceptor. These advancements bring us closer to unraveling the secrets of interstellar objects and preparing us for the next unexpected visitor from beyond our solar system. The story of Oumuamua is a reminder of how much there is yet to learn and the exciting possibilities that await us in the cosmos. As we conclude, consider this: what if Oumuamua is not a unique event but the prelude to a new era of discovery? An era where interstellar objects become regular visitors, each with its own story to tell. As we stand on the brink of such possibilities, the question remains: are we ready to embrace the unknown and explore the mysteries of the universe? If you find this journey as captivating as we do, don't forget to like, subscribe, and stay tuned for more explorations of the cosmos with us. Until next time, keep looking up and wondering what's out there.